Okay. B part 4, properties of the Hamiltonian. B part 4, lecture 8, constant motion, example number 1. You see, given this function, the scalar function f, function of the conjugate coordinates, the p and q, that's better to write first q and p. Q and p. Both are function of t, and this explicitly, this is a function of t, so it's non-autonomous. Then you see, you give this as 2p plus q plus mt, where m is equal to 5, a constant. What are the conditions for constant motion? Okay. Now here I will display 3 conditions. One for f, another one for p, and another one for q. So let's here apply the Leibniz rule or chain rule. This is partial of f respect to t. This is just, you copy, this is already derived. Now you look at this function here and look at here. So this is q dot, this is p dot, and this case partial f respect to t. Okay, it's no autonomous system. So you just derive f respect to q over here. This is 1. So this is 1, q dot, this is q dot, you see? This here is p dot. And then substitute. Now derivative of p, f respect to p is 2. You just plug in here plus 5. Now, first, let's put it first. Let's put it here first. The condition for the function f, in this case, be a constant motion. This is a condition. Okay? You just, from the equations for the Hamiltonian equation, this we just plug over here. This is q dot plus 2p dot plus 5 is equal to 0. Again, this is the condition such that the function f is a constant of motion. Now, just for your information, just q dot is partial h respect to p, and p dot is minus partial h respect to t. You just plug it here from the Hamiltonian equation. That's the equation for the condition. Condition for f to be a constant motion. That's the condition. Now, this is observed that the condition of the constant motion is along the motion, only along the motion. You see? Now let's apply the second and third condition. Okay? Individually now. 2 and 3 are individual conditions. The first one is p function of t be a constant motion. So if p of t is a constant motion, this implies that the derivative of p with respect to time is equal to 0, which implies that p is equal to constant motion. In this case, now, I have to use this for the condition of f to be a constant motion. So all these 3 have to work together. You see? Now, in this case, I will use this individual condition and plug just on this equation over here. You see? So, in this case, you see that p dot is equal to 0. So, this constant motion of this case 2, is just q dot plus 5 is equal to 0. Or, from Hamiltonian equation, q dot is partial h respect to p. Now, this is q dot is equal to minus 5. Q dot is equal to minus 5. Attention now, this condition plus a plugging of this condition over here, leads to the equation that satisfies both constant of motion conditions. Now the third one, Q of t be a constant of motion, then this means that Q dot is equal to 0. So this implies that Q is a constant of motion. The condition for Q of t be a constant of motion, then you just plug it there. You see, you have in this case Q dot is equal minus 5. You see, Q dot is equal minus 5. I'll plug here. See, this is equal 0. This implies that Q dot is equal minus 5. Now, what is important now, you to observe the third condition, individually condition. You see, in this case, condition 3 for item 2, this is for Q2 be a constant of motion, is there. Now, the condition then is this condition 2p dot plus 5 is equal to 0. So you plug here on the right hand side, p dot is equal minus 5 over 2. Consequently, we also want that, in this case, f of p, q, p, and t be a constant motion. Then q here is equal q dot. In this case, this will be 0. So this is the condition here that p dot is minus. You see, you just plug in here on this equation, q dot is equal 0, and then you solve for p dot is equal minus 5.5. Attention now. These conditions here, 2 and 3, such that they will satisfy the condition for the function f, this has to be played together, you see? So the condition for the 3 cases, f, in this case, p and q, to be a constant of motion, okay, they will work together. You see, is this condition over here, p dot and q dot, plugging over here. You see, that's a very, very, very important here. Just then, all the 3 conditions, 1, 2, 3, for f, and individually for each one, have to satisfy what I displayed in this lecture. You see, that's it. If one of them does not satisfy, then you see, you said, okay, for q different from minus 5, okay, the condition for f, you see, has to be involved at this q dot, okay. That's it. See, that's a clear derivation for you. See?